Hey guys, so I was just wandering around with my thermometer and I stumbled across something that seems weird. How come the temperature just drops? But it's not really that low, so there's nothing weird is happening. Now, for some reason, now after you already know what I just did, but now you can see that the temperature is dropping significantly. In fact, we're at -9 when I get close. And if I increase the anger, it'll get even down to -13. However, the temperature fluctuation only happens within a certain range. That way it's you can't detect it from across the map. All right, that might have been that was kind of a weird way to start the video. I didn't really have any idea what I was going to do. But essentially this is just a temperature sensor. I didn't really have a plan for how to show this other than just standing and walking around so you could clearly see what's going on. But essentially what it does is the closer I get to the ghost, which there is an entity here, the lower the temperature on the sensor gets. And it does this using some math that I'll go over in a little bit, just kind of roughly, in my process. This is basically just concept videos on a tutorial video. Now how the model works, some of you might wonder, so I'll get that out of the way real quick. So you take a 3D model, you make about 200, you make a texture for every possibility, and then you use custom model data, and then you give yourself a stick that has negative attack speed, so you can see my attack speed indicator is empty. So if you did that, then your hand would be, you wouldn't see the model, so then you shift the model upwards. And that's kind of how I did it in Word form for you guys. And then I constantly update this thing every second I update it. Now I also need to add the randomness so that it fluctuates a bit randomly, but that's super easy to do. The trick here is doing the fluctuations based off of an anger value. Now how I kind of did this was I already knew what I wanted it to look like, so I hopped into Desmos, which is an online graphing calculator, and I started playing around with some variables. So here we have n is anger, and a is just n+1 because if you use 0, you're going to have some weirdness. So anger in the game is a scale of 0 to 10, but in here it's a scale of 1 to 11 technically. This will go up to 1 to 11. So we can change the scale, and you can see the graph that I made here. This is a very complicated formula that I probably overcomplicated just because I wanted to show you the kind of locking to values. But this is the core formula I used. So you have 170, which is 17 degrees with a decimal place of accuracy. And that's kind of the max it can be. And then we can also, y equals -130 would be the minimum it can be, but usually you can't get to that stage easily. But let's go y equals -130 anyway, and let's pop into settings, and let's go like this, and let's make it red, and let's make it dashed. All right. So these are kind of our bounds, and the x-axis is a measure of distance from the location. So essentially, we calculate the distance first, which is done using my MacLeod data pack, which is linked in the description on my website, the cloudwolf.github.io website. There is a download for the math data pack. The math data pack essentially does this. So if I go to reading and I go to temp, here's our temperature reading, but I need to get the distance. So let me go into reading / main 20 tick. All right, so this is how we get the distance. So I grab the coordinates of the player, XP, and I use threading, so this is multiplayer compatible. It doesn't look like it's multiplayer compatible at the moment, but it is. I just use a threading technique, so these fake players will be updated once for every player in the game. So anyways, these fake players get updated for each player's coordinates, and they're subtracted from dx, dy, dz with xg, zg, and yg, which are the ghost coordinates, and this can work for multiple ghosts as well. So you subtract these and you get the x, dy, dz. Then I do the distance formula, which is x squared plus z squared square rooted. So I do dx squared plus dz squared. I don't care about y because y is just going to be used to determine if you're technically on the same floor as the ghost. You don't want to have it picking up the ghost from underneath a floor. That might be confusing. Then we feed that into inmath, and we feed this into inmath. So this is your x squared, here's your z squared, and here's your x plus z. Then you play math:root, which is a very fast function. I'll play it for you right here. It's 38 commands, and the command count doesn't change. And what it does is it gives you a very accurate value of the square root on outmath. And so we move outmath onto temperature so we can manipulate it. So essentially, this root function uses Newton-Raphson's approach with 4 stages. So it's accurate for numbers near my initial guess. And my initial guess is like maybe 12 or 100 or 20, I forget. So it gives you a 3 decimals of precision square root number. So if I do scoreboard display sidebar math, you can see that out is changing with a 3 decimal precision. So it's 4.561 blocks away. 1, 2, 3. Yeah, about that. And it's very accurate. So you can see that as I go further away, I could probably limit the range. I could probably limit the range because we know that we don't care about the distance when you're X blocks away. But it calculates the distance from any distance right now. And it's pretty accurate. Granted, if I go like 1,000 blocks away, you see, yep, fast square root overflow, input too large. So if you're too far away, it'll have overflow issues because your input can become maxed when you're calculating, and then you lose decimals and you go over the max integer value. Which it seems like this isn't the max integer value, but when you're doing the math involved, I believe that it calculates out to become over it. So just be careful. Obviously, we don't care about distances too far away. You can tweak the algorithm so that it works for bigger distances but gives you less precision. But anyways, so that's how you get the distance. And then we have the temperature function. And the temperature function takes the anger of the ghost and it adds 2 to it because I figured that the way that this equation came out did not look perfect. I think it adds 2. So it adds 2. It was like a little, when the anger was 0, you really couldn't get enough fluctuation to determine that it was any different. And then I basically implemented this function up here into the way that Minecraft works. So it works a bit differently than just plugging in these variables. So to make this function, I basically was like, all right, so I want it to be 170 at the maximum. And I want it to be 170 around 5 or 6 blocks away. So what I did is I plugged in -120, and I kind of knew that whatever I'm working with is going to be some kind of a slope that has some kind of a subtraction from the slope so that it gets less after a certain point. So then I just played with some numbers until I got a formula that worked. And this works pretty good. So you can see that when the anger is 0, you have a slight dip down to 111 degrees. So it is detectable with anger 0. Granted, Minecraft's rounding doesn't get you quite there. So let's just go with 14. So you get down to 14. So there's some detection here. You're not 100% certain because of random values that will be added on later. But when you pop up to anger 1, then you start to get a little more confident. And you can scale this guy, but it'll always start to dip after about 5 blocks. So you have to be basically in the same room as the thing. And I'll use the blue formula because the blue formula is a little bit easier. If it's less than, and then I just need to fix this one thing. If it's less than -130. Okay, well, it doesn't, this second formula doesn't show the negative stuff too well. So let's just add that on. So you can see that at level 10, it gets all the way down to 130, but then it would be clipped. So then I just have to take this formula and implement it into the game. To add those limits, you just say, well, if your result is below 130, set it to 130. If your result is above 170, set it to 170. And to implement it, it's kind of complicated. So we have this -190, and you may say, why 190? But that's just because of some of the ways that things moved. I manipulated variables so that I could get it working with MC. So all the division, subtraction, whatever, 36, you don't even see 36 here, but it does come up. But yeah, so that's the formula for making the thermometer. And I'm pretty happy with it. If your ghost is just a little bit angry, you'll definitely be able to tell almost within evidence. It has to get it has to get up to anger level of 4 for you to detect like pure evidence that this thing is that this is a freezing temperature coast, but you'll still detect freezing stuff at lower levels. And I do have, essentially, if I want to toggle this so that it'll never give you evidence, I could just say, like, if it's not supposed to be evidence, then you lock it to like 1. So this would basically lock you to 1 if your temperature is less than 1. Yep. So you can see even when I get up to anger of 10, at worst you'll hit 0. So it should be 10. At worst you'll hit 1. So people can't call that as evidence. So they'll be like, oh, it's 1 degree, right? So yeah, and I'm gonna add positive and negative fluctuations, so that's like a pretty easy thing to manipulate. All right, so that's pretty much the whole concept, what I want to show you guys. It does work in third person. I think, to me, the model looks pretty good. I'm sure that you guys don't like voxels. Not everybody likes voxels. But if you thought this was cool and you want to see more from it, let me know. Leave a like. And tell me if there's anything you want to see covered, like a tutorial. Because I don't really have too much on mind right now. All right, other than that, thanks for watching, and I'll see you next one. Peace.